In this lesson, let's learn about deductive and inductive reasoning and what's the difference between the two. We'll do a couple of problems, but the first one wants us to determine if the conclusion below uses inductive or deductive reasoning. First, let's understand the difference between the two. Inductive reasoning is what we determine to be a pattern or a rule based on examples that we see or a few sets of data. Deductive reasoning is based on logic and facts and statements given to us. So let's look at the example given to us. It says there's a myth that an eelskin wallet will demagnetize credit cards. So the conclusion is that the eelskin wallet will demagnetize credit cards because the skin of the electric eels used to make the wallet hold electric charge. So the hypothesis is that the skin of electric eels holds an electric charge. Right? This is the myth, right? Skin of electric eels holds an electric charge, right? And the conclusion, right, is, or this is the second part of the statement says that the eel skin wallet will demagnetize credit cards, right? This is the hypothesis and this is the myth. The myth says the skin holds an electric charge. Based on this, the hypothesis is that the eelskin wallet will demagnetize credit cards. But the other part of the statement tells us that eelskin products are not made from eels, right? So this is the hypothesis, and the conclusion is the myth cannot be true, which means that the eelskin wallet will not demagnetize the credit cards, right? So let's analyze this. Are we using inductive or deductive reasoning? Well, inductive reasoning would have been using examples. Here, we're using logic and facts. We're basically saying the hypothesis is that eelskin wallet will demagnetize credit cards, and it comes from the myth that the skin of eels holds an electric charge. So let's say this is true. But since we know that eelskin products are not made from eels, this is not true, right? So basically what we've proven is eelskin wallet will not demagnetize credit cards. This conclusion is true because the product eelskin wallet is not made from eels, and therefore it cannot hold an electric charge anyway. Since this is based on logic and facts, this is deductive reasoning. I deduced that since an eelskin wallet is not made from eelskin, right, then there's no question of it demagnetizing cards because it does not hold an electric charge. Therefore, this is deductive reasoning. Let's use the second example. Part B says all of the students in Daniel's algebra class are juniors, right? So, and John takes algebra. So what we know is John takes algebra, right? John takes algebra. And we can say that all the other students in the class are juniors. These are two statements given to us. These are two examples given to us, just some data sets. But it is possible that John takes algebra with the juniors, but himself is not a junior. John could be taking an algebra class with 50 juniors, but himself may not be a junior, right? That's an example that I can come up with, which basically says that John may not be a junior, right? So this is, if this statement is true, then we based it on inductive reasoning, not logic. We assume that because John's class has all juniors, that John himself is a junior. That's based on a certain set of data that we have, but not all the facts. So this is inductive reasoning. Okay. Now let's try part 2. Part 2 wants us to draw a conclusion from the statement given to us. Statements are, if a polygon is a triangle, then it has 3 sides. right? If a polygon has three sides, it's not a pentagon, and polygon Q is a triangle. So if polygon Q is a triangle, then polygon Q has three sides, right? If polygon Q is a triangle, then polygon Q has three sides, right? And if it has three sides, then polygon Q is not a pentagon. That's the conclusion. Polygon Q is not a pentagon because if it was, it wouldn't have three sides. If a polygon Q is a triangle, I can use this statement to say that it has three sides. And if a polygon has three sides, which is a related conditional, then it is not a pentagon. So polygon Q is not a pentagon is the conclusion that we were looking for. Okay? So what we've learned here is inductive reasoning is based on certain facts. John takes algebra. All of his classmates are juniors, so I can induce that John must be a junior. But this can be proven false by a simple statement. What if John was in the class but not a junior? He could be a senior taking an algebra class with 40 other juniors. If I can find one example, then I can prove a statement wrong which was based on inductive reasoning. But a statement based on deductive logic, right, or deductive reasoning cannot be proven false. So in order to prove that a statement is absolutely true, we must use deductive reasoning.